So section 2.3, number which one? Number? Okay. H is a strong word, I heard that. Oh yeah, good, okay. That's the one you were asking me about earlier. Alright. Let me let that guy warm up. But in the meantime, let me ask you this. We've only covered very basic... Only she's allowed to talk a long time. Only very basic equations. Right? We've only done like if I'm adding something. I did push it a little bit to see who can handle multi-step, but we haven't officially gotten there yet. The homework is not going to go beyond dividing or subtracting, adding, stuff like that. Nothing crazy yet. So there is a section. So real quick, let me start off with this kind of thing. If I said, what are you going to say, Jeff? I don't know, man. If I said, check to see if x equals 2 as an answer. Right, check to see if x equals 2 is an answer to this. How do you do that? Yeah, plug it in. So I'm not asking you to solve it. I don't want you to add 7 on that. All the problem is asking you is to plug the value in and see if what happens. What's going to tell you that it is a solution? Got to put up some insulation over here, something. All right. Yeah. So for this problem here, you would just plug that in to see if it works, right? That's what the idea of a solution is. Is when x has this value, then this statement is true. That's what it means to be a solution to an equation. So sure enough, when you plug a 2 in for x, what do you get?
8.
8 minus 7. Which is 1. So is this true?
Yes.
Yes. When x is 2, this is true. So what have you tried? Is x equal to 3 a solution?
No.
Right, how would you show that?
Not true.
That's how you would say it, a different way. How would you show it? Yes, cool. So what happens when you plug it in? When you plug a 3 in, what do you get? 4 times 3 minus 7. Is that equal to 1? Well, let's see. 12 minus 7. Sometimes you have a little question mark there. We're checking it. 5 does not equal 1. Therefore, 3, not a solution. Because it doesn't make it true. I like it. So whenever we solve an equation, we're trying to figure out what value of x makes this statement true. I like it. Sweet. So there will be some problems that are technically beyond what we can solve, but it's not asking you to solve it.
What about that 155 problem?
Look at that. Kick ass. You're like my segue person. So like I just said, there are problems we can't solve yet according to what we've talked about in this class. Some of you guys might be able to solve some. But yeah, let's look at 155. Wow. There it is. So again, I know that there are several people out there that could solve this. If you solve this, I'm going to take points off because that's not what the instructions say to do. It says check to see if those are solutions, right? So how do you check for number 1? How do you check to see if u equals 3 is the solution? Take a minute and see if you can do that. Yes, ma'am?
What was the wording in the question? Did it say simplify or solve or?
So the instructions here are determine whether a number is a solution of an equation. Determine whether each given value is a solution to the equation. It doesn't say, now if it said solve the equation, then you would start adding 4 divided by blah, 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 right?
When you say simplify, because I see that a lot.
I love it.
Does it mean like set up a problem a certain way, or does it just mean solve?
So what do we solve? Problems. So we solve equations, yeah, and with an equal sign. What do we simplify? Expressions that don't have an equal sign. So if I said simplify 16 minus 2, Another word for simplify, or another expression is carry out the operations. Right? So that's what simplify means. Or if I said 4u plus 7u, what can you do with 4u plus 7u? And it would make what? They are like terms. It would make what? 4u plus 7u?
11.
Yes. 4u plus 7u is 11u. That would be simplification. You can't solve it because you don't know anything specific about the expression. Here, I know that this expression equals that expression, and I can see when is that true. So I can solve it. What values make that true? This one, I don't know a damn thing. What does 4u plus 7u do? I don't know. I bet I can make it 11u. What's it do? It didn't tell me shit. I got to stop. That's all I can do. I like it.
What if it's like 4u and 7a?
I love it. So simplify. How do you simplify 4u plus 7a? You go. Done, Jeff. I was done before you even gave it to me.
Right.
I'm that good. You can say it just like that. So why not? Are these? What's the magic words
Not
there?
like terms.
They're not like terms.
Right.
These are like terms. I can consolidate how many u's I got. Here I can't consolidate anything because they're not like. They're not the same thing.
Right.
Cool. These back. Oh, I forget your name. What's your name? Yotsahani. Hey, all right, cool. You can grab that. Okay. Oh, sorry. Let's actually do this problem. Do you guys get this problem? What about 3? Anybody think it's a solution?
No.
Because what happens when you plug it in 8? I got to put 3 where?
And then you.
Wherever there's a U, I'm going to put it. I'm going to see if that value makes it work. I like it. So it's just like substitution. We've done that kind of thing before. If I told you A is 7, everywhere you see an A, you're going to replace it with 7. So here's telling me U is 3. Everywhere I see U, I'm going to put a 3. So 8 times 3. Is that equal to 4 times 3 plus 40? 8 times 3 is? Minus 4? 20. Is 20 equal to 12? No.
Just what I missed.
This. We're about to do another one. So we're doing problems from section 2.3, right? That deal with seeing if certain values are solutions to equations. Last time we talked about solving equations. This time we're talking about checking to see if something works in an equation.
Yeah.
So what about did anybody do the other one?
Yeah.
U equals 11? I like that. 1 and B. It's good. So the same way, right? Instead of putting a 3 in there, I'm going to put 11 in there. So 8 times 11 minus 4. What's happening?
Sorry.
Let me catch up. You guys are like, come on, math boy. Right, faster. 88 minus 4? 84. This is 44 plus 40? Check. So that is a solution. Winner, winner, chicken. Cool. I like it. All right. But it's important to know what it means when you solve an equation. What does it mean when you get to the end? That means when U is 11, then this statement is true. And we'll learn later that, there's only 3 things that could happen here. There's only 3. There could be one answer. There can actually be an infinite number of answers. Or there could be no answer. So we're going to learn that later this semester, but most of them will have just the one answer that makes it work. I like it. Cool.
Jeff,
Yes, sir.
on 50, this in the morning.
I'm sorry. Give me one second. I'm parching.
On 50,
Oh, and you got it set up? Okay, good.
Alright, so does the negatives matter?
Where are we talking about?
Or 150?
I do for science.
156?
No, 150.
150?
Yeah.
For numbers, it looks like.
So like when you plug it in, when you plug the 3 in,
Yep.
it's supposed to be -6, so does that matter?
Totally matters. -6 is not the same as 6, right? If you work for a company and they say, Johnson, what's our profit? And you say 6,000 and it's really -6,000, that's a big difference. Not only did we not make money, we actually lost money. Get out of here, Johnson. I can save some money by not paying you anymore, right? So the point I'm trying to make is, you got to be careful. Just because they both say 6 doesn't mean -6 is the same as 6. They're completely opposite. So yeah, it totally matters. I like it. So how about, is that decent? So I mean, be really careful. I appreciate it if you're able to solve these. It's not the question, right? The question is check to see if these work. So you just plug them in, see if they work. That's how you check a solution to an equation.
Just give a yay or a nay.
You say, you gotta show me something.
Well, yeah.
Okay, and then just say yes or no. I like it. Beautiful. Okay, cool. Anything else from homework that I skipped over, need to address? Yes, sir.
On 2.4, do we have to show the work? Or do we just show the multiples?
Don't worry about it. You can always get ahead. Nothing wrong with that. So we're going to talk about this today, but this is actually a section that you should probably be able to get into and do. Because we know about, if I said tell me the multiples of 4, you can just start spooning them off, hopefully. What's the multiples of 4? 4, 8, 12, 13, okay. How far apart are multiples of 4? That's crazy. So that relates to, is that cool? Did I answer your question? So it depends on the question. So like, for example, list the multiples less than 50. You don't have to show me any work. You just can list them. I know some of the lists can get a little long, but oh well, right? But there's no work to show. I like it. You don't have to show me 2 times 1 is 2 and 2 times 2 is 4. Yeah, no. Now what's really interesting is this. Let's get into this. Stay with me now, D. You guys know how to check to see if a number is divisible by, well, 2 is easy. How do you know if a number is divisible by 2? What kind of number would it be? If it's even, it's divisible by 2. I like it. In fact, this is the definition of an even number, it's divisible by 2. How about divisible by 3? No, you'd hope so. Real quick. The reason that doesn't work, one reason that doesn't work, how far apart is every even number from the next one? How far apart? 2, 4, 6, how far apart are they? 2. How far apart are odd numbers?
3.
If you don't think about it, you'll say 3. Now think about it and say the right number. 2. 1, 3, 5, 7. Those are the odd numbers and they're separated by 2. I like it. So don't think that the 2 is now it's got to be divisible by 2, but every even number is separated by 2, every odd number is separated by 2. If you add 3, you're going odd, even, odd, even. You're not getting all the odds or all the evens. Okay, I really want you with me. So to see if a number is divisible by 2 is easy. It's just got to be even. To see if it's divisible by 3 is kind of freaky. Give me a number that's bigger than 20 that's divisible by 3. 33. Give me something else even bigger.
90.
66, 90. I love it. Now watch this. 3 plus 3 is what? 6 plus 6 is what? 9 plus 0 is what?
9.
These are all divisible by 3. So what ends up happening is that if you add up all the digits to any number, and the result is divisible by 3, then the whole damn thing is divisible by 3. So for example, I know it's freaky. For example, if I wrote this number down, I got to be careful now. Oh, that'll work. All right, I'll stop there. If you add up all the digits, what do you get? Add up all the digits. 21. Is that divisible by 3?
Yes.
So then this is divisible by 3. That's freaking awesome.
Can you go slow?
Say again?
Go slow.
Instead of repeating, go slower.
Sure. If you add up all the digits in any number, and the result is divisible by 3, then that entire number is divisible by 3. Same thing works with 9. And that kind of makes sense since 3 goes into 9. So if you add up all... So has anybody ever heard this before? Alright, so real quick. This is not your fault. But I'm so sick of the lower grades saying, calculators exist. We made calculators. You better know how they freaking work, or else they're going to take over. You work for me now. Shit. So less and less people know that. It used to be everybody knew this. And now we're all like, we got to be able to work with numbers on our own and not just totally rely on the calculator because we punch the wrong button and we're going to like buy too many whatevers or not have enough money or whatever. Right? This used to be, everybody just used to know this. 9 especially, 9, give me some multiples of 9. 18, 1 plus 8 is 9. 27, 2 plus 7 is 9. 36, 3 plus 6 is 9. So like 1,008 is divisible by 9 because 1 plus 0 plus 0 plus 8 is a multiple of 9. It's actually 9 itself. Is that cool?
Yes.
All right. Good. Is that one of the Muppets or something? It sounded like one of the Muppets. Or was that your own thing? It just sounded
I
like
can
one of
do
those.
many voices.
All right. So we got 2 even. We got 3 and 9. You add up the digits, and if they're multiples of those, they go into them. That's kind of freaking cool. 5, you should all know. 5, you should all know. How do you tell if 5 goes into something? Ends in 0, 5, 11. So the day that that's not known is the day I got to retire. I can't even put up with it. So everybody should know about 5. I'm going to go a little beyond the book. If a number, what do you think? If a number can be divided by 2 and 3, then you can divide the number by 6.
Yeah.
If I can divide something by 2 and divide it by 3. So if I have a number and I can divide it by 2 and 3, I can divide it by 6. That's how you check to see if something... So an even number, where all the digits add up to a multiple of 3, I can divide that by 6. Oh, everybody can. All right? So this one it's even. It's even. And all the digits add up to a multiple of 3. Therefore, this can be divided by 6. Anybody have a calculator or just want to do it?
I'll go up 1.
2.
0, 8, 2, 2, I think. Check me out. Close.
Yep.
Solid.
Yep.
Correcto.
Correcto.
Alright, that's my one and only skill. I should be able to do that. Math. Alright, but some of you guys might not think that that's important to know. I don't care, because I'm going to make you have to know that. But you should just know. It should be just something we know. I don't want to totally depend on this technology that we created. We have to know what it does. Alright, let me think. I'll show you this, but it's... How do I tell us if 4 goes into a number? This gets a little interesting. It's a little freaky. Let me stay with me now. This is kind of interesting. 4 goes into any number where the last 2 digits are divisible by 4. What are they teaching over there? Do I yell at you guys like that?
No, but when I'm in that class, it's the complete opposite from this class over there on Mondays and Wednesdays.
Oh shit! All right. So for example, I want to start here because this is where it's going to make sense why this works. Are the last 2 digits divisible by 4?
Yeah.
Yes, because 4 goes into 24. So 4 goes into 124. Why is that not surprising? 4 goes into 100. So of course 4 goes into 100 and something else that 4 goes into. since 4 goes into 100, 4 goes into 200. So 4 will go into 200 and anything else that 4 goes into. And so forth, and so forth, and so forth. So if I make this long-ass number become a 3. There. Does 4 go into it? Yes, because it goes into 16. It might seem like magic. What's up?
This is wizardry.
Yes, Harry. No. Sorry. No Harry Potter? Okay.
Expelliarmus.
You're a mathematician, Harry. Oh, shit. But yeah, I mean, I really think about it. Is everybody cool with 4 goes into 100? Is that cool? 4 goes into 100, right?
C.
So 4 goes into 104. 4 goes into 108. Is that cool? If 4 goes into 100, 4 goes into 200. If 4 goes into 100, 4 goes into 300. If 4 goes into 100, 4 goes into 1700. 4 goes into any multiple of 100. So 4 goes into 16. And 4 goes into blah, 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 100. I mean, I really... Any of the beginning, 4 goes into it automatically. I really want this to make sense. So if 4 goes into 100, does 4 go into 1800?
Yeah.
Of course it does, because 4 goes into 100. So does 4 go into this number? Yes, because it's a multiple of 100. Now if I add some multiple of 4 at the end, it still goes into it because it goes into the whole first part and now the last part. That's why I only have to look at the last part. Come on now, I got some of you with me.
Gotcha.
If I didn't get everybody, it's okay. But it's a cool rule to know. Okay, I just hate that you guys aren't shown this anymore. It just kills me. You should know this and be working with it since
Because
way early.
all of our math teachers are on the verge of suicide. You're like literally
shit.
the first math teacher that's like, yay, math. All the other ones are like, yay, the clock is almost done.
I'm sorry.
Yeah, they're all math teachers.
I agree. There are a lot of people who
miserable.
teach math who are there for the wrong reasons. You should only be teaching something if you really love it. Right? Anyway, well, I've had teachers that were teaching stuff, they obviously did not love it. And it makes for the worst class ever. Alright, that's enough of that, sorry. Okay, so those are some divisibility rules. I might ask you some very straightforward questions about, does 9 go into this number? So you do need to, I'll tell you this for sure, you need to know 2, 3, 5, and 9, and 10. Maybe I should put 4 in there. You guys can handle 4. Good. Yes, I'm going to do it. If I ask you, you might say no, so I'm going to put it in. I can ask any of those, and without the use of a calculator, you should be able to tell me, without actually doing the long division, if those numbers go in. So if I said, does 9 go into this number here?
No.
Why not?
Because
Does 9 go in? What's the rule for 9? Same as the rule for 3. What's the rule for 3 or 9? Add up all the digits.
oh yeah.
So I'm not saying the answer is not no, but you got to give me the reason. I didn't even try to make this work, so maybe it works for me. So 13, 20, 26, 28, 29, 36.
So yes.
Is that divisible by 9? Yes. So the whole thing is divisible by 9. Do you guys see? Do you see? Okay. You see it? Okay, good. All right. So that's in this section. Where am I? 2.4. So this whole section here, starting at 225, is asking you this question. Oh, they do have 4 there. Sweet. 2, 3, 4. They got 6?
Yeah.
Shit, yeah. Sorry. So remember, well, how do you tell if 6 goes into something? If
2 and 3 going through.
2 and 3 go into it. So real quick, I'm not going to put it up here, but how can you tell if 12 goes into something if
2,
3
3, 6.
and
6 going
4? Because 3 times 4 is
12.
12. Cool. And 3 and 4 don't have anything in common. That's the other big thing there. All right, but I'm not going to put that up here. That's a little freaky. Now, what kind of number? What does prime number mean? When I say prime number, what does that mean? Does it mean like prime steak? Like, ooh, it's really good number. Prime rib. Sorry, I don't mean to offend any vegetarians. Prime rutabaga? No. What does prime mean? Do you guys know? A prime number. What's a prime number? And you're like, dude, if you keep saying it, I'm not going to know. Okay. All right, you ready? So, if I said factor 18, there's a few different answers I would take. How do you factor 18? 9 times 2. What's another way to factor 18?
6 times 3.
6 times 3. Any other way to factor 18? Become a 3, Jeff. Say again?
18 times 1.
Beautiful. I love it. 18 times. You can always do the thing times 1.
Prime is where it only gets 2.
Beautiful. 17. How do you factor 17? If that's the only way to factor it, is a prime number. This number is called composite because it's composed of more than just this. I love it. I love it, sort of. Is it coming back?
Yeah. Yes.
All right. In fact, there is a search for the largest prime number that is continuously going on. Do you guys, anybody even realize that? You're all like, that's for you, math people. There's no known pattern to the prime numbers. Can you guys attempt to start giving me some prime numbers? I'll start us up. 2, 3.
7.
What's the next prime? Something else? 6 is 2 times 3.
5.
5. Then
7.
9 is 3 times 3.
13.
11. And then 13. All right, so forth, so forth. Right, you can go get the first 1,000 prime numbers, you can just Google that and it'll give it to you. It's crazy, right? So there's no pattern that we know of. There's no like, I added 1, then I added 2, then I added 4, then I added. There's no like easy pattern to it. So people are trying to find a pattern, including me, sort of, in my spare time. Because if I found that pattern, I'm going to have my name on it for the rest of eternity. It'll be a Waller pattern. Yeah. Sorry. It's just something, you want your name known for something. I'm probably not going to find it. There might not be one. There might not be a pattern, so I don't devote a lot of time to it because it's like, well, that might be crap. What's up? There is? You got it? Your teacher solved it. Sure, yes. You almost had me. Okay. Alright, so that's composite numbers, like this section here. Prime and composite numbers. So what about 43? Is that a prime number or a composite number? Yeah, and you got to be real careful. For example, 91, is that prime or composite?
Composite. 9 times 9.
9 times 9 is?
8.
Prime.
That looks like it's prime, but it ain't. Notice what number is definitely missing from that list. 2, 3, 4, 5, 6. I can even do 8. I can do but 7, there's no pattern. There's no way to tell if 7 goes into a number. Does 7 go into that number? Does 7 go into that?
Yes.
Yeah. 1, 7, 21. 7 times 13. So don't look at a number and just go on your gut. You actually got to check it out sometimes. It's not immediately obvious. What's the only thing about a number that would tell you it's definitely not prime immediately? If it's even, kick ass. If it's even, 2 goes into it. So it's got to be at least odd, but even then you can't just go, well, yeah, it's odd, it's prime. Okay, are we semi-decent there? You might have to do a little bit of trying some stuff out to verify if it's prime or not. I like it, because the evil numbers like that look prime, but nope. Okay, cool. Blah, 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 blah. Now you got some other stuff here. This one's not very long. And then this guy, this should be... Section 2.4 and 2.5, I sort of felt like I didn't need to say too much about them because they are very reviewish. But you guys kind of all forgot about prime numbers. That got me a little worried. But they make sense now, right? When I say prime number, we all know what I'm talking about. Si, senor. When I say prime factor tree, does that bring back any memories? You know, like, are you math people doing some weird gene splicing? Let's make a math tree.
It's like 81 and then 9 and 9.
I like it. So 81,
3,
9 times 9.
yeah, then you break that down, then you break that down.
Oh, you help me out so much. And then you got your little, this is what I call, get ready, this is what I call the DNA of the number 81. I broke it all the way down to its constituent parts, all the way down to its prime parts. That's the DNA of 81.
Yep.
Do you guys remember doing this kind of thing, making a prime factor tree?
Freaking time.
It's remarkably useful, believe it or not. This is not just some exercise in, God, I got to do something to keep these kids busy. I use this when I teach my Math 110 class. We actually use this even in some higher level classes, this kind of idea. So you guys are just going to get used to how to do it. So you guys take a minute and do this one. Yeah. I feel like I've been talking too much. Make a prime factor tree for 720. It was a minute. There's a few different ways you can start this off. By the way, is it divisible by 9?
Yes.
Because 7 plus 2 plus 0 is 9. See how useful that is?